Hey everyone, thanks for joining me for another video. And this is going to be part two of our binomial relationships, little umbrella term I coined in the last video. So, last video we dealt with expanding perfect squares, and we were able to, well, perfect square binomials. And we were able to come up with a general formula for working with these that's easier than writing out the entire expansion. Now, we are going to look at another special case in this video, and we're going to be looking at this idea of the difference of two squares. And the name will become apparent very soon, but this concept deals with a special type of binomial product kind of forms. So the first example I'm going to give you, I'll actually write two and we'll do it side by side like we did in the last video. So our first one is going to be expanding x plus 2 and x minus 2. Okay? And our next example, let's do 9n minus 4 and 9n plus 4. Okay, cool. Once again, if you'd like to pause the video and practice your expansions, feel free to do so and check back in for the explanation. But what I'm going to do here is, once again, expand. So we looked at the FOIL method and this idea before of all of our elements of each binomial interacting with the other. So we're going to first look at the first ones. So x multiplied by x will give us x squared, and x multiplied by negative 2 should give us negative 2x. And then positive 2 multiplying by x will give us positive 2x. And then 2 multiplied by negative 2 should give us negative 4. Now, what do we see here? Well, we have the same term here, 2x, but one is negative and one is positive. So we can add these like terms, and we'll notice that these two will cancel out because negative 2x plus 2x just gives us 0. So these terms will cancel out, and we'll be left with x squared minus 4. Okay, cool. Let's try our second example. So we have here, first our 9n's will multiply together, and that should give us 81n squared. And, 9n multiplied by 4, by positive 4, will give us positive 36n. And negative 4 multiplied by 9n will give us negative 36n. And let's zoom out a little bit. And our final terms, our negative 4 and our 4 are going to multiply. So we'll get negative 16 here. But wait a minute. Once again, we have this relationship in the middle. First, we've noticed that kind of this one stays usually, this one stays, but in this example, our middle two terms cancelled out. Well, here, these ones, we have a positive 36n, and from that we're going to subtract 36n. Once again, that'll lead us to 0. So I'm left with 81n squared minus 16. Now let's pause for a minute. What kind of common trend do we see between these two answers and the respective questions? Well, in both of them, all that we got left with in the end, once we simplified, was the square of these equal terms. So we had x squared. And then from that, we subtracted the square of our second. Same thing here. The square of 9n is 81n squared, and the square of 4 is 16. And we, once again, had this subtraction. So we can say that the answers led to a difference of two squares. So that's pretty much what we're showing, right? We have, when we talk about a difference, usually we talk about subtraction. So we have one square subtracting from another. So writing a general kind of formula for this, we can say that whenever we have two binomial products, both with equal terms, so for example, a plus b and a minus b, so both with these equal terms here, but with one b being positive and another being negative, we can say that when doing these type of expansions, we notice a pattern of the first element squared, and from that we subtract the second element squared. This is our general formula for the difference of two squares. Because here we can, if we were to do this manually, we'd get a squared minus ab plus ab. So those are going to cancel out, and then minus b squared. So with all binomial products of this form, when expanded, will give us a difference of two squares. I'll see you guys next time.